Hey everyone. So in this video, I actually wanted to walk through, I guess, a few hints and tips about AZ-900, the Azure fundamentals. Now, I hadn't taken this exam until Tuesday, and I'd not taken it because I've done a lot of other exams. I've done obviously like the architect expert, the DevOps expert, the data, the security, the admin engineer certifications, done all of those, but I just never did the fundamentals. The reason I took it is really twofold. A number of people have actually emailed me asking, hey, do you have anything to help with AZ-900? And I'm about to release my Azure Masterclass just on my YouTube channel. And I was curious about what level of detail you need for AZ-900. So I figured I'd take the exam and kind of find out. I was having a bit of fun as well. I was going to try and speed take it. I had a bet with some colleagues I could finish in under 15 minutes. I actually finished in 10 minutes 30 in the end. And I did pass. I got 940, which means I got 2 questions wrong. So you get 60 minutes, and my test was 31 questions. So it's about 30 points a question. And what I want to really walk through in this is just, I think, some key points that may help. Now, I want to stress this is not all encompassing. Again, I took the test, I didn't look at the syllabus, I didn't study, I still haven't. So this is really just based on what I saw, I think the key constructs you need to know. If you look at kind of Thomas Maurer and Tim Warner, they both have phenomenal sets. I see them constantly posting about AZ-900. They're super smart guys, they're brilliant instructors. Go and look at their content. So that's the place to go for a real in-depth AZ-900 study. This is going to be maybe an hour of maybe like a study cram for the really things that I think you need to know and that will help. But definitely go and look at those guys' material for sort of the top quality stuff. So again, 31 questions, 60 minutes. It says it's a 90-minute exam, but that includes kind of the check-in and survey stuff. It's actually a 60-minute. And I took it at home. All you need is a computer. They want one monitor attached. You just need a camera, a microphone and speakers. Doesn't need a headset. What you do is you actually use your camera to take a picture of driving license, you, and then kind of the 4 views around your workspace to make sure you're not cheating. So again, you can't have a multi-monitor setup, one display. And so when we think about what do we need to know, I think you need to start off with governance at a fairly high level. So when I think about governance, the first part of that is obviously identity. Now, we probably have an idea that on premises, we have kind of Active Directory. That's that sort of Kerberos, NTLM. We have users, groups, machines joined to that. I can do group policy. Now, in the cloud, we have this Azure AD thing. And Azure AD is great for things like RWARF, OpenID Connect, SAML, WS Fed. It has built-in federations to thousands of SaaS apps. So if I'm going to get started in the cloud, I have to have an Azure Active Directory. Now, by default, you'll get kind of an on Microsoft name. You can add a custom domain name, so you could match kind of the domain name you use on-prem, so saviltech.net, for example. Now, I can create cloud accounts. I can create users directly in Azure AD. If I didn't have an Active Directory, great, you'd probably do that. I need to populate it with accounts. If I have an existing AD, though, I don't want to recreate separate accounts. I want to be able to synchronize my accounts up. So you're going to use a component called Azure AD Connect. And Azure AD Connect is going to replicate your user and group objects up into Azure AD, so the users get a consistent experience. I can also optionally send up a hash of the password hash. It's not the original hash stored in AD, it's a hash of the hash, 1,000 iterations, etc. So you can't reverse it, it's sorted. So now I'd have actually the same hash in there. That would enable me to authenticate directly against Azure AD and authenticate in Azure AD. If I don't want to send up the password hashes, or if I do but still want to authenticate against my on-prem, then I can still do either something called pass-through authentication. That's where now there's kind of a service bus queue where an authentication request goes and waits, and there are agents you deploy on-prem that listen to that queue, do the authentication, send up a yes, no. The other option is I could absolutely just do regular federation. So now I authenticate here, actually will bounce me authenticate here, and I get a kind of SAML token back. For all of these, as the user, I can still get a seamless authentication experience, i.e. I'm not getting prompted to authenticate for things that trust Azure AD. For federation, you just get single sign-on. For password authentication, and if I'm using the password hash, we have seamless sign-on. The experience is the same. If I'm on a machine that has line of sight to a domain controller and I'm authenticated against AD, I'm good to go. So understand, I need Azure AD. If I'm getting started, I need to populate it with accounts. The best option if I have an AD is I want to replicate them using Azure AD Connect. So that's kind of part one. I have to get the identity right. Once I have the identity in Azure AD, again, I mentioned there's a whole bunch of kind of built-in existing federations to other SaaS apps, software as a service, and I can utilize those. And one of the things I can do up here is something called conditional access. So conditional access lets me say, hey, for conditions, that could be a particular app, particular group of users, particular locations, particular risk level. So I can determine the user's risk using Azure AD Identity Protection. That's an Azure AD P2 feature. I can have these conditions, and then I can require certain things. So for example, I might say I require MFA. So again, we can do MFA up here. I could require my device to be a known device, hybrid joined. It could have to be healthy according to Intune. So I can do a lot of things in the Azure AD, but conditional access is huge. It helps me control. And again, conditional access is a P1 or above feature. MFA is now available across all of the SKUs, even the free ones, as part of security defaults. But if I want to use MFA as part of conditional access, then it's that P1 Azure AD feature. So I need to get my identity in place. Conditional access can be used to kind of control things. Okay. I have all the users in Azure AD. There is something called administrative units. So I can use these administrative units to kind of break up users into these units and then delegate particular users to be managed by different groups of people. If you know Active Directory, you have kind of organizational units. This would be a kind of equivalent. I can delegate certain people to manage certain users within Azure AD. So that's an admin. That's a fairly new feature. So it probably won't come in the exam, don't know, but just be aware that kind of functionality is coming. So this is all about identity. Now then we start to think about, well, what about my Azure resources? So we organize our Azure subscriptions. That's where we create stuff. And in an enterprise, I'm probably going to use management groups. So we have kind of this root management group that by default lives under our Azure AD tenant. And I can then create a hierarchy of management groups. And the things we can do with management groups are, I can apply a management group level role-based access control. This is where I have roles, and a role is really a grouping of actions I can perform against certain Azure resources, and then I grant those roles to groups or users. So for example, I could say you're a virtual machine contributor. I can create VMs, I can manage them. There are also things like owner, contributor, reader. They're more generic. Owner means I can do anything and I can change the permissions. Contributor means I can do anything, but I can't change the permissions. Reader means, hey, you can probably work that one out for yourself. So with RBAC, I have roles, I assign them, that role to users at a certain scope. And I say users, ideally it's groups, at a certain scope. In this case, my scope is a management group level, and it will get inherited down. So within these management groups, wherever that hierarchy stops, at some point, I'm going to create a subscription. And once again, I can apply RBAC there. Any RBAC I set at the management group will get inherited down. And I can also explicitly set RBAC at a subscription. Now, additionally, in addition to RBAC, I can also set policy. Once again, this will get inherited down. Policy is super powerful. If you think about in ye old days on premises, I want a resource. I make a request to the admin, say, hey, I need this resource. The admin would look at my request and they'd say, well, no, you can't do that public IP, that's a security risk. You can't create things over there. In the cloud, especially with things like DevOps, I can't have some human being checking things as part of my process. So we need guardrails, and the guardrails define what we can do, what meets our compliance requirements, and enforces them. So that's what Azure Policy does. So Azure Policy could say, hey, you can use these regions. You can use this type of storage account, i.e. it must be GRS, it must replicate to another region. You can't use the M series, it's too expensive for dev. And I might have sort of dev and prod structures in there. And again, they get inherited down. So that's super powerful in terms of controlling what someone could do. So if I was like, hey, you need to stop someone deploying to a certain region, well, I would use policy to do that. Hey, I need to give someone the ability to manage VMs. Well, that would be role-based access control. And then I can also do budget. Budget enables me to specify kind of a dollar value. There's metrics as well to say you can spend this much. And I can configure alerts at certain threshold percentages. So hey, at 70%, call this action group. So an action group is usually used for Azure Monitor, and it's the response of an alert. Alert could be a metric, it could be a type of log, but essentially an action group defines a list of actions. Send an email, send an SMS message, send the Azure app on your phone, call a webhook, call a ITSM. So I can do those. So at 70% of my budget, send an email. At 80%, send a more aggressive email. At 90%, send threatening guard, whatever you want to do. So I can set these three things at my management group, and they will get inherited down. I can also set those three things at a subscription level. Now, when we talk about subscriptions, and I know this is one of the questions I got wrong, there are different types of ways I can get a subscription. Now, there are ones that I'm going to get as part of an enterprise agreement, where there's account owners. I can just do pay as you go. There is a free subscription. I had no clue what free subscription limits were or anything else. Make sure you know those things. But that's a super useful thing. If I have MSDN of Visual Studio, I get a certain amount of credits. So understand there's different ways to get subscription, and there might be different limits and capabilities on those. So have an understanding of what they are. So within the subscription, I can apply those things as well. Within a subscription, we create resource groups. And I think of a resource group as bringing together things that share a common life cycle. They're going to get created together, they run together, they're going to get decommissioned together. It's all the components that make that service work. So if I had an application and it had sort of some web backend, web front ends, it had a database, it had a load balancer, I'd probably put all of those things in a resource group together. And once again, I can apply RBAC, policy, and budget at that level. So you can kind of see, and I can have lots of resource groups, but a resource, i.e. a virtual machine, a storage account, a SQL database, lives in one and only one resource group. I cannot nest resource groups. It's flat. So in here I might have a VM, I might have kind of a storage account, I might have some kind of load balancer, whatever that might be. I have all the bits that make that application work. Probably lots of VMs if I have a load balancer. Now I can do things like RBAC directly to a resource. We don't. The lowest level we ever go for RBAC is at a resource group. There are certain types of automation that may go and apply permissions directly to resources. We do not play in that world. That's something else does entirely. Now, when I have these resources, when I have these resource groups, when I have these subscriptions, these management groups, there's a very useful type of metadata that I can apply, and it's called tags. A tag is just a key value pair. That's all it is. And I can assign these to a resource group, a resource, a sub, a management group. They're there to help me manage things. A common tag might be a cost center or department. It might be an app. it could be an owner. The things that are useful to me. I can use these to search for things, to organize. I can use them for billing APIs. So when I think about cost, I can run billing reports. How much did this subscription cost me? How much did this resource group cost me? How much did everything under this management group cost me? How much did everything tagged with cost center X cost me? So again, if I'm trying to maybe see something about, hey, I want to be able to track costs on something, how would I do this? What would I use? Well, if I created a tag for my cost center or project, I'd be able to see that in the billing reports. So tagging is super powerful and it's just key value. I can really put whatever I want in there. So that's some of kind of the key construct things. Now, how do we interact? How do I actually go and use Azure? So when I think about, okay, we've got the Azure cloud and I want to interact and do stuff. The obvious one is kind of the portal. There's portal.azure.com, I can go to that. And there's a whole different list of kind of browsers you can use with that. The key point here is you can go and look these up, but it's like obviously Edge and Chrome and Firefox and Safari, which means, hey, if it's Windows, Linux, Mac OS, it's going to be able to use that. Then you'll hear about kind of the Azure CLI. Again, there's versions of that for all of those things. Then you'll hear about, well, PowerShell, and there's an AZ module. Well, the AZ module runs on PowerShell Core. PowerShell Core is cross-platform. Windows, Linux, Mac OS, as is the AZ module. So essentially, the three core ways we think about interacting, and of course there's a REST API as well, which will work for anything that can do a RESTful call. I can use across platforms, Windows, Linux, Mac OS. It's just going to work across those. So if I think about how do I interact, any of those kind of major platforms is going to work. Now, when I actually think about creating something, yes, I can create things through any of those. Behind the scenes, Azure is actually JSON. If you go and look at like resources.azure.com, if you create things in the portal, there's normally like an export. And even if you've created it already, there's an export kind of button. It will show you the JSON. This is called an Azure Resource Manager template. That's a declarative technology. And I've got another video that talks about imperative versus declarative. But essentially, declarative means this is what I want the end state to be. I'm not telling you how to do it. This is what I want it to look like. Go and make it happen. Excuse me, thirsty. So behind the scenes, it's all JSON. And so if I want to create things in a very consistent manner, if I want to make sure I'm deploying it exactly the same way across environments, the best way to actually provision things is an ARM template. And I can call those from any of those things, but I create an ARM template, which is JSON, that defines all of my resources, variables, and I apply that to Azure, and it will make it so. Hey, create this storage account. I want this storage account of this config. I want these virtual machines. I want this scale set. I want those things. Just do it. So when I think about creating things, the best option is to use an ARM template. Again, I can see ARM from like the portal. I can go and look at existing resources. I can go and look at resources.azure.com. But if I see anything about, hey, you need to create things, you need to make sure it's consistent across multiple environments, can I use an ARM template? If I can use an ARM template, that's the answer. Now, there are other technologies out there. Things like Terraform is cross-platform. So that would let me do this same declarative deployment across Azure and AWS and Google Cloud and VMware and Kubernetes. The list kind of goes on. There's providers for everything. I doubt there'll be things about that, but realize that's another declarative technology that I could absolutely use. So that's when we think about actually provisioning things, and make sure you understand there are limits. So just regular Azure subscriptions, there are limits. Obviously the 3 account, there are limits. So just kind of understand those things that are out there and exist. Oops, what's going on there? There we go. I made some notes, so I'm just checking I don't forget stuff. So when I think about now creating stuff, remember Azure is this cloud. But really there's no such thing as the cloud as such. If you think about it, Azure is made up of lots of what we call regions. So we can have kind of region 1, there's another region, and there are tons of regions in the United States and Europe and Asia, Australia, you name it, there's kind of regions there now. And most of them are part of the commercial cloud, which means we can all use them. There are some sovereign clouds. Sovereign cloud would be, for example, Germany has a sovereign cloud, China has a sovereign cloud, US government has a sovereign cloud. So you have to be part of those countries or organizations to use that. But essentially we have regions, and these are all connected to this kind of massive Microsoft backbone network that's one of the biggest in the world. It spans the world. They had submarines dropping cables under the Atlantic. So it's massive, super performant network. And when I deploy things, I deploy to a region. I want to deploy to South Central US, to East US, East US 2, West US, Europe, whatever that might be. So I can think about, I deploy to a region, but a region is actually made up, typically, of more than one data center. So I might think, well, yeah, there's like a data center there's another data center, and let's just say there's 3 data centers, just picking a number almost completely at random. These are actually exposed in a number of regions today, and you'll see them called availability zones. Within your subscription for each region, you'll typically see AZ-1, 2, and 3. These are not physical. There's not actually a building with 1 written on it. My AZ-1 in my subscription might be someone else's AZ-3 in their subscription. But they are consistent among any individual subscription. And the point of the availability zones is they have independent kind of communications and cooling and power and water. So when I think about a resiliency, I would typically deploy my resource across different availability zones. Then I have some called a standard load balancer to distribute the traffic among those. So what an availability zone is giving me is resiliency at a data center level. So if a data center failure needs to be survived, I need to use availability zones. So that will give me resiliency. The blast radius of an availability zone is a physical kind of building. So if I want to be resilient against a data center level failure, I need to deploy to availability zones. Then there's another construct of resiliency, and this kind of lives within a particular building. We're going to get even smaller in our pen now. If you think about it, there's just racks and racks of servers called stamps. These are all deployed. So the other construct I can actually use is something called an availability set. So an availability set is essentially 3 fault domains. So you can say fault domain 0, 1, 2. And what happens is the resources I deploy will get distributed over those 3 fault domains or racks. So an availability set would give me protection. The blast radius will be a rack level failure. Top of rack switch, power supply units, an individual server. But it would not protect me from a data center level failure. So data center goes down, my availability set is in the same data center. So availability set protects me from a rack server level failure. Availability zone protects me from a data center level failure by sort of distributing across them. Of course, if I want to survive a region level disaster, then I have to deploy to multiple regions. So if I want to survive an entire region being unavailable, I need to deploy to multiple regions. Then I have to balance my traffic between them. Something like Traffic Manager, which is DNS based, or I could use Azure Front Door if it was HTTP, HTTPS. So that's how I could do that. It's like 7 a.m. I just worked out for 3 hours, so I'm pretty thirsty. So they're kind of some key constructs I think about during deployment. Okay, so let's actually think about what do I actually do within these things. So the first construct often we need is a network. And I can actually think about, so if we sort of zoom out for a second, let's go back, bigger pen. A virtual network, I can think about, well, I have my subscription. So I have a subscription. Within a subscription, I can use many, many regions. So I pick a particular region. And then within that region and that subscription, I create a virtual network. A virtual network is just one or more CIDR ranges. And a CIDR range is that notation where you see kind of the network. So it might be 10.1.0.0 slash the number of bits that define the size of that network. So like a /16. So that would be the equivalent of a 255.255.0.0 subnet mask. So we write those in CIDR format. Normally it's the RFC 1918, the 10 dot, the 172.16, 192.168 things, but you can use other ranges if you want. If you own them, if you're bringing them, you can use that as well. So I create a virtual network. So again, it can't span regions, it can't span subscriptions. If I'm using multiple regions, I would at minimum have a virtual network per region. And then I break that up into virtual subnets. And that subnet would be a portion of the overall IP space of the virtual network. So I'm creating that virtual network. So this is where I can then create stuff. So I create virtual machine scale sets, Kubernetes hosts. Many things can actually go and interact with that network. Now, if I have other virtual networks, I might have another VNet in the same region. It could be just different group, maybe prod, dev, whatever. Maybe it's in a different subscription. Maybe it's in a different region. I can connect VNets together. So I might have another VNet in another region over here using peering. So peering just uses the Azure backbone to basically connect them together. The IP space cannot overlap. It has to be unique IP space. It is not transitive. So notice this VNet is connected to this VNet is connected to that VNet. They cannot talk. I would have to add a VNet connection between those as well. So key point, peering lets me connect VNets. The IP space cannot overlap. It is not transitive. Now, I could deploy a virtual network appliance. I could apply Azure Firewall to perform routing. I can use something called user-defined routes to specify next hop and make it transitive. But natively, it is not transitive. It will not do that. So that's cool. I've got this VNet thing. And now you've got your on-prem network. So this is your kind of on-premises network. And I want to be able to use that. Now, absolutely, I could give things a public IP address. And there will be times you want to do that. I might have something I want to offer a web service to the internet. Now, yes, I have a VM or a virtual machine scale set, and I'll get into these in a second. They have something called a private IP. These are IP addresses dynamically allocated from the IP space of the virtual subnet they are placed on. I can add a public IP. I could give this VM a public IP as well. That's generally a very poor form. You don't want to do that. If I want to make something available, I would use a load balancer. So I have some kind of load balancer, then I can have multiple back-end members to answer that traffic. It would also then give me resiliency, give me scale. And then I could give that a public IP. So that would be a public load balancer. But if I'm on-prem, I probably don't want to go via some public endpoint. I want a private connectivity. I want to think about making Azure an extension of my network. So we have a number of ways we can do that. And the first is, if I was just an individual machine, if I was just a machine sitting out here, and I just want my machine to be able to connect, I can do a point-to-site VPN. So I have to have a gateway in Azure that I connect to. So the first point is I have to have a gateway subnet. So this is dedicated to the Azure gateway. And the recommendation is a /27. It can be as small as a /29, but we like /27 It gives us future flexibility. Maybe I want an express route gateway and a site-to-site and point-to-site gateway. So deploy gateway, and then I could kind of connect in. I would then get an IP address from the gateway, and I'd be able to talk to the resources on that VNet or connected to that VNet via peering, whatever, just IP routing. If I want to connect my entire network, I really have two choices. One is I can do a site-to-site VPN. This is going to use IPsec. Again, I have to have that gateway subnet, so I need the gateway subnet, and I have to deploy the VPN gateway into so I need a subnet to deploy the gateway. The gateway is a managed component by Azure, and I say, hey, I want a VPN gateway into that gateway subnet. So the two things I have to have. And now I can establish that VPN connection. So now anything sitting on this network can go and talk. Anything on this can go and talk to this. I've now essentially connected the networks together. So this is encrypted. Again, it's IPsec, but it is going over the public internet. So this is just going over the internet. Latency, I don't know, it's going over the public internet. It's going to vary, it's not consistent. And all I can do over this mainly is stuff that sits within that virtual network. I say mainly, so I'm going to talk about something else in a second that muddies it slightly. But that's the point. It's a site-to-site VPN connection over the internet. Now my other option is, do you remember I drew this kind of line? And I said, hey, there's this Microsoft network. And then I have the regions. Well, you can kind of think about that Microsoft network. And again, once again, I've got kind of a VNet sitting in here. And then I've got my network. So Microsoft have a number of edge locations. So these are network edge places. This is where Microsoft extends its network to connect to other carriers, so it can like internet offload, but also so it can do dedicated private connectivity. This is ExpressRoute. So what I can do as a company is I can work with an ExpressRoute provider, and they will either give me kind of a dedicated connection into a meet me location, or maybe if I've got an MPLS, it can become a node off of my MPLS. But essentially now I've connected my network to the Microsoft backbone. So that's ExpressRoute. So with ExpressRoute, it's a dedicated connection and it's private. So it's dedicated, it's not going over the internet. I pick the circuit speed I want. Latency is going to be consistent. This is a private connection, not bouncing over random hops and random places in the middle. Now, when I establish this connection, all I've done is connect my network to the Azure or the Microsoft backbone network. The next thing I have to do is a peering. A peering lets me actually use the resources. So if I wanted to get to stuff on a VNet, then that's going to be private peering. So private peering basically says, hey, I want to connect to that IP space. That's private peering. And I can peer to multiple VNets, and it would all go via this meet me location. So that's private peering. But remember, there's also other stuff. There's also things like storage accounts and SQL and lots of other great services in Azure. Well, if I want those, which are normally public-facing, internet-facing, to be available via my ExpressRoute, well, then I turn on something called Microsoft peering. And with Microsoft peering, these routes that are normally advertised to the internet now get advertised by there as well. And there's a route filter I can use to be more specific. I think that's probably more detail than you'd need. I think the key point will be private peering. I'm using ExpressRoute to connect to a certain VNet. Microsoft peering is used to connect to PaaS services. So Azure SQL Database, Cosmos DB, open databases, storage accounts, things that don't live within a VNet. Now, I said there's this kind of murky middle ground, and there is something called private link. And I'm not going to go into a lot of detail. Essentially, private link lets me take a resource, and it actually now has a private endpoint within my VNet. It has an IP address that represents the service. So technically now I could VPN in to that VNet and still access that PaaS service via private peering or via a site-to-site VPN, because that service is now kind of got its manifestation as a private endpoint. Again, I think that's putting more detail. I would focus on, hey, I want to get to Azure. I can do a point-to-site VPN, connects my machine via a gateway, which is managed by Azure. It's a redundant set in a gateway subnet. If I want to connect an entire network, I can use a site-to-site VPN, which is an encrypted IPsec connection over the internet. Or I can use ExpressRoute, which is a dedicated connection. It's not encrypted because it doesn't need to be because it's private. And then I can do private peering to connect to a VNet-based resource, Microsoft peering to advertise a subset of resources in selected regions via route filters over my connection. So they're kind of the key things I think about connecting the networks together. We talked about the network peering. Again, one of the other cool things you could do is if you imagine I had kind of a hub network, and then I had a number of spoke virtual networks that all connect into this one. As I mentioned, I could apply something like Azure Firewall to enable those to talk to each other. But also if I did have kind of that on-prem network and I established some kind of connectivity, one of the things I can actually do is to say, hey, use remote gateway and allow gateway transit. So now these could actually use the connectivity of the hub to go through. So that's kind of a nice, and that would work site-to-site VPN or ExpressRoute. So that's kind of something nice I can do in there. When I do have my virtual network, obviously security often comes up. So if I think about my VNet, and then I have a certain subnet, for example, the way we can actually control the flow of traffic is actually something called NSGs, Network Security Groups. So network security groups let me say, hey, I'm going to allow certain flows, and that could be based on IP address. There's something called service tags. So I can name particular Azure services. So I could let it talk to Azure Storage. I could let it talk to Azure SQL Database. So I can use NSGs to control. So if I wanted to, for example, let 443 in from the internet, for example, I would have to create a rule on the network security group on my subnet to say, hey, allow 443 from the internet to this particular VM. So NSGs, I think about locking down a subnet. I apply them at the subnet, and they're enforced at the NIC, but we very rarely will apply it to a network card. You can do that as well. Generally, we create these rules, we apply it at the subnet. Now, another alternative to NSGs would be something like Azure Firewall. So Azure Firewall is kind of this edge device that I would make all the traffic flow. And again, if I was using Azure Firewall, then I would modify Azure Firewall to allow that type of traffic to actually come through. So that's another option for controlling those things. I already talked about load balancer. If I have a scenario where I have kind of lots of resources offering the service, we use an Azure load balancer, which is a layer 4 construct. So it's operating at so it's layer 4, which means it's kind of UDP, TCP. If I was using a web service like HTTP, HTTPS, then I can instead use App Gateway. App Gateway is a layer 7, so it understands HTTP. Then I can do cookie-based affinity, path rewriting, SSL offload, things like that. So that helps me, again, balance traffic, use health probes to check, is it really there? So those types of things. So it's probably as much networking, I think, at a super high level. From a storage perspective, the simplest thing generally is a storage account. So we have kind of you create a storage account, and a storage account lives again within a certain region. I typically want the storage account to be in the same region as the compute that's going to use it. One of the big configurations we have is the resiliency type. So there's always 3 copies of the data. There's never less than 3 copies of my data. If it's all within one kind of storage stamp, that's called LRS, locally redundant storage, locally resilient storage, one of those things. If I have availability zones, I can actually spread those 3 copies over the 3 AZs in the region. That would be ZRS. that would now spread them over AZs. So that all lived within a certain region. Now, they actually pair regions. They're hundreds of miles apart. So a region is actually typically defined as a 2 millisecond latency envelope. So a region is not necessarily, hey, it's one building. The buildings might be spread out. They're generally fairly close together. Microsoft buys sort of big stamps of land and they put multiple data centers in it. But it could be more distributed as long as it lives within that 2 millisecond latency envelope. Obviously, we have lots and lots of regions. So I have another region over here. Microsoft create pairings of regions for certain purposes. Those paired regions are generally hundreds of miles apart. So they'd survive any kind of natural disaster. It shouldn't affect both. If it did affect both, we probably don't care anymore anyway. So we pair those, they're hundreds of miles apart, they're in the same geopolitical boundary. The exception is Brazil, that actually pairs with South Central US because there's only one region in Brazil. But everywhere else, these are paired in the same geopolitical boundary, so there's not data sovereignty challenges. So the point is, with these pairs, I can turn on something called GRS. So with GRS, now it replicates the data asynchronously, and there's 3 copies over here as well. There's also, for certain services, I can do a read access variant, so I can read but not write to it. Within a storage account, I can do kind of blob, which is generally great for any kind of file. I can do files, which gives me SMB access. I can do tables, which are kind of key value column storage, and I can do queue. So hey, I want to put something on, I take something off. So those are all just natively available with a storage account. Behind the scenes, when we create virtual machines and I create a managed disk, it's using a page blob to actually store that. It just abstracts it away for me. So on a storage side, if I want resiliency from a regional outage, for example, on my storage account, I would pick GRS or GZRS, which uses ZRS locally and then replicates it over. One of the cool things you can now do is you can pick the failover. I can initiate the failover if I deem I need to failover, and it will actually show me, hey, this was the last sync time, you would lose X minutes of data. Because it is asynchronous, there potentially could be some data loss, probably will be some data loss. Okay, so that's networks, that's very basic storage. The last thing I want to touch on is the services you're going to actually create. And I'm kind of old school on this. I'm just going to get my notes for a second, just to make sure I don't forget a certain type of service I want to cover. All right. So if I think layers, and I often think about, well, there's compute, there's network, there's storage, and there's a hypervisor. Could be Hyper-V, VMware, compute, my servers, network, my switches, my cabling, storage area networks, whatever that might be. Then I have my kind of operating system. Then I might have various runtimes and middlewares. Then I have kind of my app and my data. And the reason this is important is when we start looking at the cloud, the responsibilities shift. So on premises, so just on-prem, this is all me. It's my responsibility. I have to worry about the physical machines. I have to worry about hypervisors. That's all my job. Now, when I move to the cloud, the first one we see is IaaS, Infrastructure as a Service, and the line is there. So now the shift is, this part is me. The hypervisor, the physical storage, the physical network, the physical compute, in this case it's Azure's job, it's Microsoft's job to make sure that stuff. So when I move from the cloud, I'm no longer responsible for those things. I care that it's working, I care about SLAs, but it's not my job. When I go to IaaS, and this is really the lowest level I do in the cloud, I'm responsible for the OS and above. So I'm patching the OS. I'm worrying about firewalls and configuration and anti-malware and runtime versions of my app. There are things to help me. Azure Backup can help back it up. There are extensions to help configuration. There's many things to help me do the job, anti-malware, etc. but it's my responsibility to make sure I turn those things on. Next layer up, we think about platform as a service, PaaS. So here, all I care about is the app and the data. That's it. I'm not worrying about an operating system or runtime or middleware. Not my job. And then finally, there's kind of SaaS, software as a service, like Office 365. Really, nothing there is me. The only thing I tend to do in SaaS is I might do configuration. I'm not deploying SharePoint or Exchange or anything else, but I have to configure those things. So in a SaaS world, I might do configuration, but I'm not doing deployment. In a PaaS world, well, I'm going to use tools for DevOps to deploy my app. I have to make sure I'm worried about my data resiliency, so that's on me. But I'm not worried about any of the underlying stuff that runs it, the operating systems. In an IaaS world, hey, I do care about everything down to the OS, but I never care about any physical element. That's completely outside of what I do. It's nothing I'm going to use. So that's important to kind of understand. The cloud is consumption. I pay for what I use. I pay for when the VM is running. So if I shut down the VM, I deprovision it, I stop paying for the VM. Doesn't mean it becomes free. So again, we think in an IaaS world, often we think of kind of VMs as first. That's the lowest level. Well, even a VM, if we think about it, so I've got my virtual machine, well, it needs storage. So there's an OS disk. So just because I shut down the compute and I stop paying for the compute charge, I'm still paying for the disk. I might have data disks, so I'm still paying for those. Then there's like network cards, there might be IP configs. It's important to realize, so it's consumption. I pay for the storage, I pay for the compute, I pay for network egress. I don't pay for ingress to Azure. I never pay for data into Azure. I pay for data leaving the region. And when I peer networks, there's a small ingress egress charge for peering. But that's kind of a fundamental point. When I move to Azure, what I pay for is consumption charges. And realize there are different resources that make up an overall service, like a VM. So yes, if I shut down the VM, I stop paying for the VM. But unless I delete it and it's disk, I'm still paying for the storage stuff. So I have different types of service we can use. So let's kind of think about those services. So obviously we have virtual machine. I think that's very familiar. I create a VM. There's different SKUs. There were ones more storage optimized, compute optimized, memory optimized, ones with NVIDIA CUDA cards for GPU. Huge range of them. I pick different sizes. I can change these things, but it requires me to essentially shut it down and restart it. There's a restart to change the size. So I have properties of the virtual machine. Then we have virtual machine scale sets. This is still IaaS. The virtual machine scale set is really the idea that many types of service, we have multiple instances. And really, they're just tin soldiers. I stand them up. If one falls down, we just stand another one up in its place. We don't really care about its state. So virtual machine scale set, essentially I have kind of this gold image, and then I specify properties like the minimum number I want, the maximum number I want, when I perform scale. And it will take care of deploying the virtual machines. It will take care of deleting and creating them. Again, I want to scale horizontally to really optimize my costs. So I think about virtual machine scale set, it will look at what's the resource use, what's the schedule I've defined. Hey, I need 3 now I need 7, now I need 2, now I need 5. It will dynamically delete and create them based on what I need at that moment in time. So I'm only paying that consumption for what I actually need at that moment, which is huge. Other cool things are like this image, this gold image can come from the image repository. It could be the Microsoft images, it could be custom ones I create. If I put in a new version of the image, it will automatically, on a rolling update, replace all of the deployments in the scale set. I'm not even patching anymore. It will just go and deploy that stuff. So these are all still kind of IaaS. Obviously, VM scale sets are starting to push over, but fundamentally, they're virtual machines, just some things to help me. Now, then I start moving into things like containers. So remember, a container is where we virtualize the operating system. Virtual machines, we virtualize the hardware. We have a virtual machine which has a certain amount of virtual CPU and memory and storage. With a container, remember, we have kind of the host, and it is essentially got the kernel, which is shared, and then it creates these container instances that have isolated kind of namespaces and IP stacks and resource controls, but they're running on a shared OS, a shared kernel. So we're virtualizing the operating system. So in Azure, we can do containers. There's services like Azure Container Instances, which is really containers as a service. And what we would have is we'd have some kind of repository where we have our images. So like the Azure Container Registry, the ACR, and then image is just layers. There would be like a base OS layer, then maybe there's some config, then there's an app, and I just deploy that image to a container. But there's a lot of requirements for containers. Are they healthy? Are they distributed? Someone has to create them. Someone has to scale the worker nodes. There's a whole orchestration layer I need for containers. So that would be kind of Kubernetes. And in Azure, there's a managed offering called AKS. And the great thing about AKS is you don't pay for the management components. I'm not paying for the Etsy database. I'm not paying for the scheduler, the API, the brain. I don't pay for any of that. I just pay for my worker nodes that actually I run the container, the pods that run the containers. Another really cool thing I can do is, yes, I have my kind of workers, and it does that via a kubelet, which is like an agent that helps manage stuff. It can actually also hook into ACI via a virtual kubelet. Then it can actually burst and use ACI if it needs to. That's kind of some cool stuff. So now we're getting into the kind of the PaaS. These are all PaaS, platform as a service. Then we have app services. And you hear like app service plans. These are like web, and mobile, an API. I create an app service plan. Again, behind the scenes, I pick a certain scale. It auto scales depending on the the SKU I purchase. I can pick different sizes. Again, it's consumption based. I pay for what I'm going to use. There's also something called an app service environment, an ACE. And ACE is dedicated to you in that there's no multi-tenant parts and it runs in your VNet. So if you ever saw something like, hey, you need to use app services, but it must run inside your virtual network, or an app service environment will give you that. But it costs more because now there's no shared components, which the app service plans have. So there's more bits, but it scales higher and it's all running inside my VNet. And app service is kind of like the initial Azure PaaS. That's kind of the ultimate personification of PaaS. Then you'll see things like logic apps and Azure functions. Now these are PaaS, but they also kind of come into this thing you'll hear called serverless. And the reason it's serverless is even app services, as part of the creation, I specify, well, how many instances of kind of the workers do I want? What size are they? So there's still servers dedicated to me. I'm still paying for boxes. And yes, they scale, but I'm paying for the whole box. With logic apps and functions, functions can run on an app service plan, or they can run in a serverless, a consumption model. I pay for the CPU I consume and the storage I do. Logic apps, I pay for the connections that I'm leveraging and the work it's doing. So these are serverless offerings. So if I see, hey, you need a serverless solution, well, that would be Azure Functions or Logic Apps. Logic Apps is really like the flow. I use these different integrations. So I have connectors, and I can have, say, hey, a connector is a tweet. Then I go and call some Azure Cognitive Service to get sentiment. Then I go and write out to something else. So I create this flow using connectors. So that would be a logic app. So it's all done kind of visually. An Azure function, it can run C#. There's a whole bunch of different languages. PowerShell is what I use it a lot for. I bind to inputs and outputs. I have triggers. Trigger could be, hey, someone calls me via a webhook. Someone via Event Grid writes something to a storage account, a schedule. And it's just going to run code. So they're kind of the core things to understand those. VMs, it's a virtual machine. VM scale sets, it's based on templates and it auto scales for me. Containers, AKS is kind of orchestration. App service plans, hey, I want to run a website. Now I could run website in containers. And then the serverless solutions. So I guess based on what I saw in the AZ-900, there's some of the things I would really make sure you know. Again, this was not exhaustive at all. Again, I've still not looked at the syllabus. I have zero real clue what's in it. But based on what I saw, I think this would definitely help if you understand these things. But again, go and look at like Thomas Maurer and Tim Warner. They've got a ton of detailed stuff. I see them posting all the time. They're super smart guys. And they'd probably be a great place to go. But hopefully this might give you a few things to help you pass. So if you're taking it, good luck, relax, don't worry about. If this was helpful, please like, comment, subscribe. And until next time, take care of yourselves.